The Shintani zeta function is a complex function that arises in the study of number theory, particularly in the context of quadratic forms and automorphic forms. It was introduced by the Japanese mathematician Takuro Shintani in the 1970s, and has since played a significant role in various areas of mathematics. The Shintani zeta function is associated with a positive definite quadratic form q in n variables over the integers. This is a polynomial qx sigma aij xi xj, where the sum is taken over all pairs of indices I and j from 1 to n. The coefficients aij are integers, and the matrix aij is symmetric and positive definite. The Shintani zeta function of the quadratic form q, denoted by zeta q's, is defined for complex numbers s with real part greater than n2 by the series zeta q sigma qxs, where the sum is taken over all integer vectors x in n-dimensional space, excluding the zero vector. Like the Riemann zeta function and other zeta functions in number theory, the Shintani zeta function can be analytically continued to other values of s, with the exception of a possible pole at Sn2. This analytic continuation is a fundamental aspect of the function, and is essential for its applications in number theory. The Shintani zeta function satisfies a number of important properties and identities, many of which generalize properties of the Riemann zeta function. For example, it satisfies a functional equation that relates its values at Sn, Ns, and it satisfies certain transformation formulas under changes of the quadratic form q. The Shintani zeta function also encodes deep arithmetic information. For example, its special values at positive integers are related to the representation numbers of the quadratic form q, which count the number of ways a given integer can be represented as the value of q at an integer vector. The Shintani zeta function appears in many areas of mathematics, including the theory of quadratic forms, the theory of automorphic forms, and the theory of L functions. It also has applications in mathematical physics, where it appears in the study of lattice models and string theories. Despite much progress, many fundamental questions about the Shintani zeta function remain open. For example, understanding its zeros, its special values, and its relations with other zeta and L functions, are major unsolved problems in the field. The study of these and other questions about the Shintani zeta function continues to be a vibrant and challenging area of mathematical research.